Hello friends, welcome to FreeCAD tutorial, and in this tutorial we will do modeling and drafting of this part. As you can see that I have already modeled it with respect to the orthographic view, and you can see that our model is matching with our isometric view. In this tutorial we will not only create a 3D model but we also create technical drawings. As you can see that I have created drawings in a FreeCAD Tech Draw workbench, and our views and dimensions are matching with our 2D drawings. So in this tutorial I will show you how you can do modeling as well as drafting in FreeCAD. So I will close this file and create a new file. You can also visit my website mechnexus.com, where I write articles and tutorials on FreeCAD. You can download my tutorial source file from here, tutorial source file page, and you can also support me by buying a cup of coffee on ko-fi.com. Your small support will help these channels to grow, and it will motivate me to create more awesome content on FreeCAD. I thanks to all my supporter, those who have supported me by buying a cup of coffee. So keep supporting, and it will help me to grow this channel, and it will motivate me to create more awesome and useful tutorials on FreeCAD. So let's come back to our tutorial. So here I have created a new file, and first thing which I will do is to insert my body and on origin plane. First feature which will be create is to create this base diameter. So I will select this top plane and click on the sketch, select a circle, create a circle, and come out of the sketch. Let's first give the dimension to this diameter, which is of 71, which we can see here. So I will select a dimension tool and give it a 71. Now I will off the origin plane. Now select the sketch, click on the pad and give the pad of 9 mm thickness, and click on OK. Now I will switch to the isometric, and now we will create this feature. So we will select this top face, click on the sketch, I will rotate my model, and here first thing which I will do is to project the outer diameter, and here I will create a 3-point arc on both the sides, and select this both the arc and apply the equal constraint. Now click on symmetricity, select this point and this axis, and select this point and this axis, and apply the dimension of 15 mm. Similarly this side. And now we will draw horizontal line on both the sides, one here, same way on other side, one here, and now I will select a 3-point arc, and give the coincidence relation, and here we will provide dimensions. Let's select diameter and give it a 47.5, and select this and made it equal. So our sketch is fully constrained. We will close it and we will add the material of 11.5. Okay, now we will add this material. So for this we will select this top face and click on the sketch, and we will rotate our model. And now here we will create a 2 3-point arc on both the sides, here and here, and we will zoom our drawing. So here is a R is a 5.5 on the both the sides. So first thing which I will do is to add a coincidence relation for both the arc to the axis, and select dimensions and give it 5.5. select this and made it equal. Now if you see, the center to center distance is of a 35. So select symmetricity, select this and this and this axis, and provide it a 35. And we will move the point of our arc, and we will create a 2 3-point arc on the both the sides, one here and one on the other sides. Now select this and this and add a coincidence, select this and this and add a coincidence. Now we will connect all 4 arc with a line. Now here is of a diameter 31, so we will select diameter and provide it 31, and we will select this and this and add equal. And now we will add a tangency relation at all possible location. Select this and this and add a tangent, select this and this and add a tangent, 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 and tangent, and tangent. Now we will see what is the unconstrained. So here if you see that center to center distance is a 35 and it is symmetric, and here center point is not coincidence for these 2 arc, so we will select this and this and add a coincidence, select this and add a coincidence. So our sketch is fully constrained. Now we will select the sketch and click on the pad and give the pad distance 18.5. click on OK. Now move to the next step, which is to create this revolve cut. So for this I will on my origin plane and I will select this mid plane and click on the sketch, and for better visibility I will switch to the wireframe, go to the model tab and off this origin plane. And now we will create a half profile, and we will create a revolve cut with respect to this axis. So let's select line tool, draw the horizontal line and then vertical line. You can also use the polyline tool, it depends upon your convenience. Now let's provide this horizontal constraint, and now let's give the dimensions. So this is the diameter 31, so I will select smart dimensions and provide this horizontal dimension 31 divided by 2, because this is a radius, and this point is of 12.5, and this height is of 9 mm, and from this point to this point is of 16, and from axis to this angle is of 15 degree, and from this to this is of 7.5. And now we will project this top edge, and we will rotate our model, select this and add a coincidence. Now select the line tool and give it a horizontal relation, and select this point and axis and add a coincidence. Now switch to the right view, select a line tool and join it, and select a dimension tool. This to this is of 11.5, and now we will project this edge. Switch to the right view, and now we will select this point and this projected line and add a coincidence constraint. So our profile is fully constrained. We will come out of the sketch, select the sketch, click on the groove, click on OK. Now let's move to the next feature. If you rotate it, you can see that cut has been created. Now we will again on our plane. Now we will create this feature, which is a revolve cut circular profile. So this is a type of a drill which is opening in our revolve cut here. So we will use the same groove features to create this profile. So we will select this plane and click on the sketch, and from here I will switch to the wireframe and off my origin plane, and now I will select a line tool, create a horizontal line, create a vertical line. Let's select the polyline tool to create our profile. Now let's add the relevant constraint, make it vertical, and let's give the dimensions. So from this bottom edge to axis is of 9 mm. If you zoom it, we can see here it is a 9 mm. So this is our bottom edge. Select a dimension from this to this. We'll provide a 9 mm, and now zoom out, and here is a diameter of 2.5. So we will give the radius 2.5 divided by 2, and let's give approximate distance of 8 mm from the axis, and now we will give the angle. So here is angle is of 118, so we will give this 118 divided by 2, and now we will zoom our drawing So here is a diameter 2.5 and this diameter is of a 5.7. So we will select this and this and give it a 5.7 divided by 2, and this diameter is of 10, so this will be the 5. And now here is it is given the 16 mm, so we will project this edge and let's see. So we get a point here, so we will select this and this. Let's add a vertical relation, or we wanted to remove the material, so this is not that much important. So we will do here the 16 mm dimension from this point to this point. So let's give it 16 mm. And now if you see here we have the edges, and let's apply the specific vertical constraint. Okay, so it is got applied, and I'm sure about that material will be get removed here. And now this diameter is of a 5.7. so now let's fix this distance. So here is of 2 mm, so let's give the 2 mm. So our profile is fully constrained, and we will switch to the flat lines. We have provided the vertical constraint here. If material not perfectly removed, then we will move this outside, because we wanted to remove the material here. So let's see how it is look like after the groove. So select the sketch, click on the groove, and from here I will select reference, and from here I will switch to the wireframe, and I will select this line as my reference, and now switch to the flat lines, and let's see. So that is okay. Now we will mirror this same features on the other side. So we will select the groove and click on the mirror, and from here I will select reference, and I will select this exit plane and click on OK. So you can see that it is got perfectly mirror on the other side. Press 0 for isometric. Now in our next feature we will create this counter bore holes. So this counter bore holes, 3 on this side and 3 on the other side. So I will select the face and click on the sketch, and now I will first create a PCD. So for the PCD we can see here it is of 47.5. so I will select the circle, create a circle and make it construction, select diameter and provide 47.5. Sorry, this PCD is not 47. Now we will create this counter bore holes. So for this counter bore holes we will select this face and click on the sketch, and there are the 6 counter bore holes, 3 on this side and 3 on the other sides. So first we will create a PCD diameter of 59. So we will select the circle and create a circle and make it construction, and from here we will select diameter and provide it 59, and here we will create a circle. We will select this axis and our construction circle, add a coincidence relation and select a diameter of 5.5. Now I will close it, and here we can see this contour bore holes detail, which is of 5.5. So we will select the sketch and click on this hole feature, and our through hole is of 5.5 diameter, and from here we will say it through hole, and here we will select the counter bore, and the counter bore is of a dia 9, so we will provide here the value 9 mm, and its depth is of 5.5 mm. So you can see that counter bore hole has been created. Now we will polar pattern it. We will select our holes and click on the polar pattern, and from here we want quantity 6, which will be equally spaced, and you can see that FreeCAD automatically took this Z axis to polar pattern my counter bore holes. Now let's move to the next feature, which is to create this dowel hole, whose detail is given here, which is of two holes of dia 5 and having the depth of 7.5. So we will select the face and click on the sketch, and now we will project the arc. Click on the project geometry, select this and this, and select a circle, create two circles, and press the control key and make these two equal, and now provide the diameter, which is of 5 mm. Now we will create this hole, so we will select the sketch and click on the hole wizard, and here our dia is of 5 mm, depth is of 7.5, and click on OK. Now to check it, switch to the front view and switch to the wireframe, so we can see that our drill hole is created. Now we will switch to the flat lines, and now we will move towards to the creation of a new feature, which is, if you zoom out, we can see here there are two holes of dia 2.5 on this face. So we will select this face and click on the sketch, and we will rotate our model. We will create a two circle on the axis. Select the circle, create one here, and click on symmetricity. Select this point, and this axis, and distance between these two holes is of 46. So select this and this, provide the 46, and select the diameter tool and provide the diameter of 2.5. select this and made it equal. Click on OK, and now we will select the hole features, and hole is of 2.5, depth we will provide approximate 11.5, so that it open in this counter bore sections. Click on OK. Now to check it, we will switch to the right view, and from here we will switch to the wireframe, so we can see that our drill is opening in this counter bore. Now let's switch to the flat lines. Now here is the 4 fillets which we can see, and we will provide the 4 fillets to our corner of our radius 4 mm, which we can see here. Now click on the fillet and select this edge, this edge, this edge, this edge and provide the value of R4. Click on OK. Now we will press our model to the isometric and we will give the approximate color as per our isometric view. So we will go to the appearances, go to the custom appearances, and let's select a color. Let's apply, close it. So this is how we have created a 3D model with respect to our isometric view. Now our next task is to create a 2D drawing of our parts. So we will first save our part. Let's say save it as a R1. Say OK. Now we will switch to the text draw workbench and we will rotate our model, and here we will select insert the page template, and here I will use the A3 landscape minimal. Press enter. So sheet has been inserted. So this is our base view. So I have put my model in this position, and now I will click on my last features and click on here insert view. So my base view is inserted here. Now I will rotate it in this direction. Okay. So this is our base view and there are the two sections. Here is a scale type. I will keep the page and say OK, and here I will rebuild it. Now I will go to the scale sections and scale is to the 1.5 and refresh it. So you can see that size has been changed. Now we will give the dimensions in our top view. So here is the frame is on, we can easily off and on the frame. So once you on the frame you will see the chord points. So let's give the dimensions. So first thing which I will do is to enter the center lines. So I will select these and these lines and go here and add a center line between two lines. So you can see the center line has been inserted. Similarly here. Now we will select this chord point and this chord point and add a vertical dimension of 15 mm, and from this center to this center is of 35. So select this and from here select a vertical dimension of 35, and this radius is of 5.5. Select radius and this is of 5.5, and here is a PCD of 59. So we will select this and this, and from here we will select a vertical dimensions and move this 59, and we will add text of PCD, and we will add a prefix here of a diameter. So dia 59 PCD. Now here it is of diameter 47.5, so we will select it. We can give the radius as well as diameter, but I will prefer to give the radius. So here is the radius dimension, and here is the radius of R4. So here I will prefer to keep my precisions to the round figure, to one figure. Now here is a radius of 4 mm, so I will select this radius and select the radius dimension and add a 4 mm. Now I will come out of the frame. So here are the center marks which I will insert. So I will select this, this, all the diameters, and click on insert the center marks. Similarly we will select this and enter the center marks, and these two, insert the center marks. Now this is our top view whose dimension we have given, and now here is a diameter 31 which we have not given, so we will select it and select the diameter and give it a 31. And now we will create a section AA. So we will, on the frame, select this view and click on the sections, and here we will select these options and give our identification label A, and if we scroll down we will see here live update. Check it. So you can see that it is a perfect, and we will click on the OK. Now we will move it. Now we will zoom to the section AA and we will give the dimensions. So first thing which we will do is to insert a center line. So select this and this, select this one and this one, and add the center lines. Click on OK. Select this and this and add center lines. Select this and this and add a center line. Now let's start giving the dimensions. So first we will give this major diameter. Select this point and this point and select the horizontal dimension, and we will add a prefix diameter and we will move it. Now select this and provide the horizontal dimension of a 31, and I will add the diameter prefix. And now I will select this point and this point and add a dimension of a 20.5, and here I will insert the center line. Select this and add a center line. Click on OK. Now here is a 9 mm dimension, so we will select this and add a dimension of 9 mm, and let's add the overall height which is of 39, and let's add this diameter. Select this and this 23. Now we will add a diameter prefix, and we will enter the center line of this hole and provide the pitch of a 46 mm. So select this and this line, and add a center line between two lines. Similarly here, select this and this and add a center line between two lines. Click on OK. Now we will select this, and from here we will select a horizontal dimension of a 46, and select this and this, provide this diameter 15, and here we will add a prefix diameter. And now here is of diameter 2.5, so select this and add a dimension of 2.5, and we will insert a diameter. It is a 2 quantity, so we will go in a note and provide the 2x, and now we will move towards the counter bore. So from this point to this point, it is of 10 mm, which is of a diameter, so we will add a prefix. Select this 10 mm and add a prefix, and here is of a 2 mm, so we will select this point and this point and add a horizontal dimension. Now from this point to this point is of 16 mm, so select it and provide a horizontal dimension of 16, and here is of a drill size of a 2.5, so we will select this cut point and this cut point and add a vertical dimension, and we will add a prefix of a diameter. Now let's create one more section view, which is of a section BB. Now we can easily off the frame and see our drawing. So if you see, we have given all the dimensions of this section AA and top view. Now we will create this section BB. So for this, we again on the frame, and we will select our base view and go to the sections options. Click on the section view, and this time we will select this option for the section, and we will give our identification label B, and from here we will select on the live updates. So our section is perfect with respect to our section view. So first we will say OK. Now we will rotate our sections. So we will move our view, and here is a rotation angle. Okay, so it is, let's give the 360. Okay, so now it is a perfect with respect to our section BB, and now we will give the dimensions. So here it is a height, we will give the 9 mm, so we will select this cut point and this cut point and add a vertical dimension of 9 mm, and we will select this point and this point, add a horizontal dimensions. So it is a 25, but it should be diameter, so we will add a diameter prefix. You do not worry about this frame, because once we off it, it will be hide the frame, our dimension will be visible. But for convenience, I move my dimensions. Now here is angle is of a 30 degree, so I will select this line and this line, and give the angle of a 30, and here is a dimension 16 is given. Here you can provide a fillet, which I have forgot. Now I will select this point and this point and give it a 16 mm. Now here is a dimension 18.5 is given, 18.5, and here is a drill. So first I will insert a center line. Now select this and this, add a center line, and now select this chord point and this chord point and add a horizontal dimension of 5, and it is a diameter, so insert a diameter prefix, and it is at two locations, so we will give here quantity 2x, and drill depth is of a 7.5. So I will select this chord point and this chord point and provide the vertical dimension of 7.5. Now we will provide this counter bore details. So first we will insert a center line for our counter bores. So we will select these two lines and add a center line between two lines, and I will select this chord point and add a horizontal dimension 5.5, but it is a diameter, and quantity is 6, so we will mention the 6x, and select this chord point and this chord point and add a horizontal dimension of 9 mm. Select the diameter. Depth of this counter bore is of 5.5, and total height is of 9 mm. So here you can see that we have given all essential dimension of section BB. You can add some additional dimension if you want, and you can add GD&T to this drawing, and then this drawing will be ready for the manufacturing. Now we will zoom out our drawing and we will place this isometric view. So to place the isometric view, we will switch to our model isometric view, and here we will set our view to the fit all, and here we will click on the snapshot view, and here crop image and no background. Click on OK, and here is our isometric view is inserted. But one thing you can see that this boundary is too much large, so here we will set the values. Let's set 80 by 80, how it is look like. Okay, it's look like okay. Now I will scale it to the 1.3, and here I increase the image height to the 90, okay. So now I will place my isometric view here, and I move my view, and let's move this top view, and I will move it so that both the views should be aligned, and let's Yes. So once you set your view, best practice is to lock its position. So lock symbol is inserted, and similarly we will do for the section BB. Place it locked. So off the frame, and now we will do some minor aesthetic point of view changes in our model. Like here is a center line is not given, so we will select this and this and add a center line and click on OK. Similarly we will insert one more center line here. Click on OK, and we can also use the angular line to create our center line. Add a center line, click on OK. Now we will also insert the center line for this counter bore holes. Select the center lines. So if you see our drawing, it is matching with our orthographic view. And now I will move my isometric view, and let's scale it to the 1.5 and increase image height to the 100 by 100, and let's see. So here I will height I will set 110, and let's set this also 110. Now I will off the frame. So this is how we have successfully created a model as well as a 2D drawing of this part. And in this tutorial we have learned how we can create a 2D drawing in a FreeCAD, and if we apply the GD&T and some minor details like materials, so we can release this drawing for the productions. So this is the very good example of modeling and drafting in FreeCAD. So this is all about this tutorial. Thank you for watching. Thank you for your valuable time.